Hello and welcome to another How to Code Well class. My name is Peter Fisher. This is a Docker containers class for beginners. We're going to be focusing on lots of different things around Docker, including what is the difference between a Docker image and a Docker container. Also, we're going to be executing commands against a container, creating containers, searching for different Docker images on the Docker Hub. Changing the container names, also a lot of command line tips and tricks that I can give you, as well as changing the user that is accessing the container, running the container, copying files from one container to the other, handling volumes and exposing ports, and all sorts of other things included. This is a very beginner-friendly course. I have got other advanced courses coming along the way. If you have any questions or comments, as always, do let me know. Put them in the comments section below and I will get back to you as soon as I can. Happy coding, everyone, and I'll speak to you again soon. Cheers. Bye. Good morning. Welcome to another How to Code Well tutorial. This tutorial is the first tutorial regarding Docker images and containers. If you haven't already, then do check out my Docker Machine playlist, Docker Machine tutorial playlist, because there's going to be some references to Docker Machine commands, and you might find it helpful to watch those videos first. I'll leave a link to that in the description below. Also at the end of this video, I'll leave a link to that too, and perhaps in a card, which is up here. So yeah, do check those out first and then come back here. So we're going to talk about images and we're going to talk about containers, and this is going to be there's going to be several tutorials because there's a lot to talk about, and I don't really think that I can fit I can't fit everything in one thing. You'll fall asleep. So for today, we're just going to focus on what the difference is between an images and a container, how to get them, and how to basically use them in a very basic manner. Okay, so I'm not going to, first of all, I'm going to talk about images. I'm not actually going to talk about containers, and the reason why is because it's like a chicken and egg scenario. You need to talk about the images first before you can talk about the containers, which might seem weird because whenever everyone talks about containers or Docker, they always refer to containers. It's container this and container that. Well, actually, a container needs to have an image for it to work. An image is basically what the container feeds off of. So you can have multiple containers that are assigned to an image. So what is an image? Well, an image is pretty much like it's a file, I suppose, or a snapshot of a container. An image, and so a container is made from an image, and you can have multiple containers of an image. The way I see it, or the very simplistic overview, I suppose, it's much like when you've got object-oriented programming, where you've got classes, class instances and objects and so forth, where you have a class, you have an instance of that class, a bit like polymorphism, where you can have multiple classes, multiple objects of a particular class. Also, classes can extend other classes. So with in the Docker's world, you can have images that extend other images. Why would you have that? Well, you would have that because if you're creating, say, a series of base images, you can have certain properties, certain attributes of that image that every child image will then inherit. So, for example, if you want to set up some security, some sort of SSH rules, some sort of config, from a very sort of base level, then you would create your image. Likewise, if you wanted all your images to feed off of, say, one particular version of, I don't know, Debian or whatever, then you would create a base image of that, and then all your other images would then extend off of that. So there is a slight, I guess it sort of starts and stops from the terminology point of view, similarness to object orientation, as well as the images in Docker and so forth. Likewise, you can have multiple containers, as I said, that are linked to the image, and those containers can have different names, different purposes. They can also have different properties. They can even have different volumes and different other configuration that you can inject into the container, and so forth. So okay, let's we've done a lot of talking now. Let's do some coding. Let's go back. Well, actually, before I do that, I need to talk about where we get these images from. So there's a couple of places. First is the public registry. So you get these images from a registry. So you have a registry that has several repositories in that registry. So, for example, Ubuntu has a repository within the Docker Hub registry. The Docker Hub registry, which I'll just show now, if I can find the tab. Yep. So the registry here, which is the Docker Hub. So I'll bring that down so you can see hub.docker.com is the place to go for public and also private, because you can log in here, repositories. So if I click on explore, so we get a whole list of repositories within this registry. Things like Nginx and Redis, BusyBox, Ubuntu, even the registry itself. So you can actually have private registries. So, for example, if you wanted to keep everything private, if you didn't want to expose parts of your infrastructure, and quite rightfully so, you would have a VPS perhaps that has this registry on it, and then you would use things like HTTPS and certifications to allow people in your perhaps development team or just team company access to the registry. Using the Docker login and logout protocols and so forth, and you would access your own images and your own repositories from your own private registry. I'm not going to go into that too much today because there's a lot involved with setting up the private registry. All you need to know is that you can have your images in either a public domain or a private domain. So going down here, there's also stuff for Debian variants, even Mongo, MySQL, the Hello World is the basic sort of template test type thing, even Elasticsearch. People have even set these things up for things like WordPress and Node and so forth. So it can be very application specific, as well as operating system specific, so like Ubuntu and so forth. Okay, so we're actually going to pull down the Ubuntu one here. So I'm just going to click on that, and we can see that this is the official repository for Ubuntu. We can see that it was last pushed 9 days ago. This is obviously going to change by the time you watch this video, perhaps. And let's scroll down. We can see that we've got these different tags of the Docker file. So we can have different tags, and each tag here is a version of Ubuntu. So we have the different tags here. We also have a latest tag. Now the latest tag in Ubuntu sense is always the LTS version of the version of Ubuntu. And if I scroll down even further, we can see a little description of what Ubuntu is, and then what the image is. And you can see here that Ubuntu is latest, always points to the latest LTS, which is pretty handy to know. And then the different things that is included with this. And then also what I want to do is scroll all the way down to the bottom. You can see some comments. And this is really handy because if you've got a problem with the image, you can come here and see if there's anyone else with the same issue. Or you can do what I've done before and just say, yo, this is not working. This is what I've done. Can you help? And normally these guys, these commenters they're very keen to help. So do check that out. There's also ways like IRC and so forth that you can channel into for help and so forth. So we've got these tags here. We can pull down the Ubuntu. Now I'm using the word tag and pull. There's also terms like commit and push. So it's very Git-esque. All right, so it's very Git-esque. So you can create an image yourself, and you can commit to it, and then you can push that image to your private or public area of this registry, which is very handy. But what I'm going to do is just get it back into the terminal, because I've spoken quite. Let's actually write some code. So let's bring that down. So the first thing I'm going to do in this terminal is ensure that I'm going to ensure that I'm running the correct Docker machine. So what I'm going to do here is just run Docker machine, and then I'm just going to do active. Now this should hopefully bring back how to code well. Yep, so we're in the how to code well Docker machine. So any image that I pull down here will be against this machine, which is pretty handy, or assigned to this machine, which is pretty handy. So what I can do is run Docker images. Now this is going to get the list of images that I have against this machine, and we can see that we don't have any images at the moment. So this would be where the repositories are, this would be where the tags are, the image ID, and so forth. The size is the file size of that image. Likewise, if I did docker ps -a, we can see the containers, and as we can see here, we have no containers at all, and that's because we have no images at all. So let's just clear that down. Let's pull down the Ubuntu image. So let's just go back to here. Let's see what we need to do. Docker pull Ubuntu. It's as simple as that. So let's do that. So Docker pull Ubuntu. Make sure I've spelled that right. Oh, I always spell Ubuntu wrong. So let's press enter. And what we're getting here is we're pulling down the latest from the latest, because we haven't specified a tag, and I'll do that in a minute just to demonstrate. It will pull down the latest by default. So here we're pulling down all the layers that are included, all the parts that are included in the in this image. So now if I did docker image is, we can see that we have this image that we've pulled down. We can also see that we have this one here, which is tagged none. Don't worry too much about that for this video. It just means that you can manipulate the image yourself and commit to it, and you've also got a record of what the latest one is. But let's not get into that too much. I'm also going to show you how to pull down a specific tag. So let's go back to Safari, bring that back up, and let's scroll down here. So we've got different tags that we can use. There's also a tags tab that we can just click on, and if we scroll down here, there's lots and lots of tags that we can choose from, which is really handy, because if there's a problem, then we can sort of revert and go back to different versions and so forth. We've got the latest tag because we didn't actually specify a tag that we wanted, so we have the latest tag. But let's say I wanted to pull down let's say I wanted just to pull down 12.04. Okay, so how would you do that? Well, let's just bring that down and do docker pull again, and then it's Ubuntu because that's the repository name, and then colon, and we want to get that specific tag, so 12.04, and we run enter on that, and this is going to pull from the library Ubuntu, and it's going to pull down 12.04. So now what we've done is we've pulled two different versions of Ubuntu, and if I was to do docker, again I can't spell that, docker images, we can see that we have the two images, the latest and the 12.04. Notice again that they both have the unidentified tag that we can play with, but again I'll talk about that in future tutorials perhaps. So what I'm going to do is remove these images. I'm just going to clear the screen to give some space. Do docker images again, and to remove an image, what we need to do is docker, and then it's rmi. Okay, so rm removes a container, rmi removes an image. So RMI, and you can either specify the repository and the tag or the image ID. So I do it by image ID because it's easier to identify, I find. So docker RMI minus docker RMI and then the image ID. So let's do that, and we can see that we've untagged the latest and we've removed all of these things, all of the parts that made up the image, all of the layers. So let's remove, and again, what I should do, just as proof, let's do docker images. We can see that we, with an S, we can see that we have just 12.04. So I'm going to remove 12.04 now. So let's do docker RMI. Now also what we can do is you can create a list of images that you want to remove. So I've already removed this one, but I'm going to just paste that one in. So I'm going to remove this one. What it's going to do is it's going to complain that this image ID doesn't exist, but then it's going to just remove that. So let's just do that now. So we can see that that's untagged, and we can see the notice failed to remove image, this image ID, because the image doesn't exist, because I've just done that. But that's a handy tip when you've got lots of images that you want to remove. Then just create a string of image IDs to remove, and regardless of whether one has been removed or not, you will remove the ones that you need. So let's clear the screen down and do docker images, and we shouldn't have any images at all, which is good. So I'm just going to do docker pull. I'm looking for, and I'm just going to pull down the latest, so I don't need to do that. I can also do latest, of course, and that's going to pull down the latest image, like so. Okay, so just wait for this to go. Okay, good. So let's do docker images again to ensure that we have it, which we do. That's great. Again, if we did docker ps -a, we can see that we have no containers. So this is the next part of this tutorial. How on earth do we make a container from this image? Well, like I said, you can make many containers that feed off of an image. So I'll demonstrate how to create a container now. So excuse me. So okay, let's create a container and create a container from this image, and we would do that by docker run, because that's what we want to do. We want to run a container. We need to specify the some flags into this, some arguments into this docker run command. So what I'm going to do to explain those is just do -- help, and I'm going to show you all of the commands that all the arguments that you can run with the run command. As you can see, there are loads. Loads and loads and loads. So we can do all sorts of crazy and wonderful things with the IP address, with the lots of stuff, with the volumes, with the MAC addresses, with the privilege modes, with all sorts of things. The two that I'm going to use at the moment are the interactive flag, which is -i. So this keeps it open. This allows you to actually interact with the container, which is handy, and also -t, which deals with the TTY, which is pretty handy. So let's clear the screen down, and I need to get the image ID. So docker images, and we're going to do docker run, and we're going to do -i -t. Now we can also do just -it for shorthand, which is pretty good. And we would specify the image ID that we want to run. So I'm going to paste that in. So we're going to run it interactively against this image ID, and the thing that we want to run within the container is bin bash. Okay, so let's just explain what that means. So I'm going to run a container, and I'm going to run it against this image, and I'm going to do it interactively, and by doing it interactively, I've specified what command I want to run, so bin bash. So running this will give me a bash shell within that container, like so. Now notice how that's changed. So I've got root at the container ID, whereas the one above here is my MacBook Pro command entry. So we're actually in this container now. We've created a container, and we're actually in the container. We're actually in Ubuntu. So if I was to do an ls, we can actually see the file system of Ubuntu. And if I was again to do perhaps cat, then etc, then get the sources list, we can actually see the sources list of Ubuntu that was used to get this image. Let's just do an exit. So this exit now is going to come out of this container. Please be aware when you're in the containers, because it can be a little bit confusing at times, not knowing which container you're in. So let's just exit and do docker ps -a. Now this is going to list the container that we were just in. So we've created the container. That was the image ID that we used. That's the container ID that we were in. Now notice that that is the same as this part here. This is the command, like I said, that we were using. It was created about a minute ago, and we've exited out of that. Docker created its name, Desperate Turing. That's quite interesting. So these names are created automatically. You can also set them up yourself. Perhaps I'll show that in a different video. But we can see that this container was created and then exited. Now, what we can do is start the container. So we can do docker start, and we can start the container against the container ID. Now what that's going to do is it's just going to start the container. It's not going to give you that interactive shell. So for example, if this container was just doing a process or doing a service, like MySQL or Apache, then you would start and stop that by docker start stop, as long as you've mapped the relevant bits and pieces together. So again, if I did docker ps -a, we can see that it's up. Now I said before, well actually I'll show you how to do a docker. We'll do a docker stop of the container, like so, and we can also remove the container. So docker rm. So notice we're not having an I on here because we're removing the container. So we can remove that container here, and we can see that that was the output that we've got. And docker ps -a should be empty, which it is. Okay, I'm just going to clear the screen. Now, before I said, earlier on, I said that we can have many containers that are fed off of an image, and that's perfectly correct. I'll demonstrate that now. What I'll do is, so we've got the Docker image. I will do a docker a docker run, if I can find it. Let's just do docker run. Oh, I'm going to need the image. So docker images, docker run, and then -it, and then the image ID, like that, and then we're going to do bin and bash. So that's going to run the first container. Notice that I've got a different container ID now because they get generated uniquely, automatically, and so forth. Now let's exit out of view. Well, actually, let's exit out of that and then do a docker ps -a. So we have one container. I'm going to do docker run again against the image ID. Now, you might think that's going to run that same container, the container that we were just in, but that's not the case. If I was to do docker run, we now get a completely different container ID. And if I was to do exit and docker ps -a, we can see that we actually have two containers. So these two containers are linked to the image. They are the like I said, you can have multiple containers that are connected to the image. So you can have multiple instances of things, which is pretty handy. I'll move it into more advanced features of containers and images and so forth down the line, but I'm going to leave this here. This is probably enough to start with. If you've got any questions though, please let me know. Put them in the comment section below. You can follow me on Twitter. My Twitter handle is pfwd. Like the video if you found it helpful. Do share it along. Do subscribe to get the next videos coming your way. Once again, thanks for watching, and I shall see you again soon. Cheers. Bye. Hello, welcome to another How to Code Well YouTube tutorial. My name is Peter Fisher and this is the second part of the Docker image, Docker container set of tutorials. In this tutorial I'm going to focus on how we can change and manipulate a Docker image once we have the image downloaded to the machine. In the previous tutorial, in the intro tutorial, I had a discussion on what the difference is between a Docker image and what the difference is between a container and the things that define the two, as well as a brief tutorial, I suppose, or a demonstration of how to pull down an image and how to run them as containers, or run containers from the images. Now, I highly recommend you check that video out, the previous one, because it will give you some insight and some better knowledge for this video. Also, I've got a Docker Machines tutorial that I recommend you watch too, if you haven't already done so. I'll put links to those in the description and the YouTube cards up here as I go along. But today we're just going to focus on how we can manipulate these images once we have them. So I'm going to ensure that I'm in the right machine. So let's just do Docker machine active, and this should return the How to Code Well machine, which it does. And if we did Docker images, we shouldn't have anything here, and if we did Docker ps-a, we shouldn't have anything there. So you can see I've got nothing up my sleeve. So let's just clear this down, and what I'm going to do is Docker pull, and we're just going to get the Ubuntu, the latest Ubuntu image. So this step is exactly what we did in the previous video. Obviously I had more explanation as to what I was doing, but we'll just wait until this gets installed. Okay, so if we did Docker images, we can get the image ID. Alright, so what we need to do is create a container from this image first. Before, in order to manipulate this image, we must get a container. Then we create this container and get into it using a bash shell. Then we install some bits and pieces, and then what we need to do is save those bits and pieces to the image so we can use it again. So the first thing we do is docker run and -it, and we've got the image ID here, and we're going to go in as bin bash. So this again will bin bash. This will take me into a shell, which it does, and what I can do is do an apt get update. So that's going to update the sources, and I'm going to install, if I just do a clear, I'm going to install apt get install. I'm going to install npm because this is something I use quite frequently. So if we go yes, so this is actually creating changes to the image. Okay, so this is creating changes to the image on this Docker machine. And as this is running through, I would like to just explain that there are things called Docker files. Now, a Docker file is what is used to actually create the images from scratch. I will go into those in more detail in future videos on how to create Docker files and so forth. But the point I want to make is that it's what I'm doing now is I'm changing the image without changing a Docker file, which in some cases is okay, especially if I'm committing it back to a registry. But it's always good if you want to start from scratch to do these changes, to have the apt-get install npm command within the Docker file as well. So then you can put that into source control and other developers can use it. But anyway, I digress. So let's do npm -v, and we can see here that we've got 3.5.2. That's fine, and I'm just going to exit out of this container. Okay, so obviously if I did Docker images, if I was to remove this image and then do a pull from Ubuntu again, I won't have the npm because this is something that I've added myself. So what I need to do is commit this image, and I'm committing it to my local How to Code Well machine. So what I do is do docker commit. In In fact, actually, I need to do docker ps -a, because I said before that container is a snapshot of an image, so we need to do docker commit docker commit and then the container ID, so it's that one there, and we need to give it a name as well. So I'm going to do Ubuntu, and I'm just going to put -npm. So what that is going to do after I press enter is it's actually going to create another image or a snapshot of that container with npm in there. And if I was working against a private or a public Docker registry which I could log into, I could then do a Docker push and push this, or Docker tag it and then push it up. So if I now did Docker images, we can see that we have a third image here, Ubuntu-npm. So that was the first one that we got, the latest that we got, and then this is the one that we have literally just created. So let's do a docker ps -a. I'm just going to clear the screen. Docker ps -a, and we've got that container that we were just in. I'm going to do a docker rm and remove it, because what I want to do is do a docker images, and I want to do a docker run a -it, and I'm going to use this image, the new image that we've got, and I'm going to run that. And actually what I'm going to do is just run npm -v. Okay, so that will print out the version of npm from the container. So if I did that, we should get 3.5.2, which we do. Now, if I was to do that against the previous image, the image that we first got from the public registry, the Ubuntu repository, so if I did npm, if I ran that against here, we will get an error, and we'll get an error because npm isn't installed in that image. It is in this image, but not in that image. So if I did that, then we get an error, a pretty nasty one, and basically that means that the executable file cannot be found in the path. So I'm just going to clear that down and do docker ps -a, and likewise if I was to, let's just do a docker rm. There are other ways of actually getting into these containers using docker exe, but I will show that to you later on. I'm going to just kill that and also kill that one, like so. So docker ps -a, got nothing there. Go back to docker images. So if we were to do a docker run -it to the original image ID, so that's the original Ubuntu image, and then if I was to just run that as bin bash and did a npm -v, we can see that command cannot be found. So I'm going to exit out of view, and I'm going to now jump into bin bash in this image and paste that in and do an npm -v, and we can see it is there. So this is how you create your images, or you update your images and you commit them. And like I said, if you were connected or logged into a registry, you could then do a tag and a push to push this stuff up. It's very important to keep committing as you go, and also, like I said, it's very important to have a Docker file that you can update as you go too, just to keep a record of what you've done. I'm going to leave it there, even though there's a lot more to this subject. I'll probably pick that up again in the following tutorials. But if you've got any questions, then please do let me know. Put them in the comments section below. Like the video if you found it helpful, and please do share it around. Subscribe to get the next set of tutorials and also the web chats that I do every week. So thanks again for watching, and I shall see you again soon. Bye. Hello, welcome to another How to Code Well YouTube tutorial. My name is Peter Fisher. This is the third part of the Docker image, Docker container set of tutorials. This is the third episode. In this tutorial, we're going to focus on how to execute commands from a Docker container once we've already got the Docker container. In the previous set of tutorials that I've done, and please do check them out, I've been removing the containers and then rerunning or creating the containers with new commands. You don't actually need to do that. You certainly don't need to remove the container in order to execute a different command against it. So this video will demonstrate how to do that. So like before, what we're going to do is do a Docker machine active. This is going to get the active machine that we are running. It should be the How to Code Well machine, and it is. So now I can do Docker images and also Docker ps -a. This is going to list out the images and the containers. As you can see, I've got nothing at the moment, so I have nothing up my sleeve. So I'm going to clear this down, and we're just going to do a Docker pull against the Ubuntu image. This is getting the Ubuntu image from the public Docker Hub registry. So there's nothing special going on here. I've explained what all this is doing in the previous videos. So we'll just wait until this is done, which it is. So now I can do Docker images and get a list of the images that we have, which is great. So what I'm going to do is I'm going to actually create, I'm going to jump in and create a container from this image. I'm also going to install PHP, and I'll explain why I'm going to do that in a minute. So we're going to just do Docker run and then -it, and we're going to run against that image, and we're going to fall into a bin bash interactive shell, and we're just going to do apt get install. So we're in the container now. In fact, I need to do an apt get update to update the sources first. So this is updating the sources of Ubuntu. I'm just going to clear that down and then do an apt get install PHP, and this is going to install PHP 7 because PHP 7 is now the default PHP version in Ubuntu, which I think is fantastic because it's the latest and greatest. And so what I'm going to do is just clear that down, do PHP -v, and actually that's PHP 7.0.8, which is great. And let's just come out of that container. So Docker ps -a will bring us list us the container that we were just in, and you can see that the status it has exited about 4 seconds ago. The command was bin bash. Right, how do I run PHP against this container? This container has stopped. Now before, what I was doing was I was removing the container and then rerunning it, or rerunning it against the image. In fact, this time it's not going to work because I've added PHP to the image, but I haven't yet committed it, so that won't work. So how do I start this container? It stopped. So how do I start it? Well, quite simply, there's a command called docker start, and you pass in the container ID like so. Now what that's going to do is it's going to start the container, but it's not actually going to put me into an interactive shell like it had done before. It's not going to run anything like it did with the Docker run, so it's not actually going to run the bin bash in the interactive shell. If I did Docker ps -a, we can see that it started. The command that it's running at the moment is bin bash. It started, but I'm not actually inside this container. So how do I do that? How do I get into this container? Well, we do Docker exec -it because we want to do it interactively. We're going to use that as the container ID, and again we're going to do just bin and bash. So this is Docker execute, so we're going to execute an interactive bin bash shell against this container like so. And again, if we did PHP -v, we can get the PHP version. We're now inside the container. Again, if I was to exit it and then clear the screen, do Docker ps minus a, we can see that the container is here, but in fact the status is up, and it's been up for about a minute. So exiting the container in that manner hasn't actually stopped the container like it did when we were doing docker run. So we can actually jump back into it quite quickly like that, and then exit out of it, and then do docker ps minus a, and so forth. Now, we don't have to always use bin bash, for instance. We've just downloaded PHP. PHP has an interactive mode. So what we can do is do a docker exe. We're going to execute interactively into this container, PHP minus a. So that's bringing up the interactive shell or the interactive we're loading PHP in an interactive mode. So we're now in the container, but we've got the PHP interactive mode has been enabled. So now I can do things like echo. Let's just do hello world. This is the simplest thing you can do with any kind of programming language. That's just going to print out hello world. So let's just exit that, clear the screen down, and do docker ps minus a, and we can see that it's still up, and it's been up now for 2 minutes. So I can switch between what I want to do. So for example, I can go straight back into bin bash and then exit that, and so forth. So I've started the container from a stopped container, but how do you actually stop a container? Obviously you can stop the container by coming out of it when you're running it, but how do you actually stop it from this point? Well, again, like the start, there is a stop command. So we run docker stop, put in the container ID, and that will stop the container. So docker ps minus a. We can see that now we've exited it, and we did that about 3 seconds ago. So what happens if I was to run the PHP command against a stopped container? Well, if I did that, it would throw a whole nasty error. So this is actually the container ID. This is the full container ID. This here is just a small snippet, the starting point of the ID. We can see that it is not running, and therefore we can't do anything to it. But again, if we were to if we were to start it and then run the interactive shell, we can do so. So let's come out of view. There's another command that I can show you, and that is if I went to docker ps minus a, there's also a way of restarting the container. So for instance, if a container is running a script and it's just crashed, then we can restart it like so. And docker ps minus a, we can see that it's up and running again. Okay, so that's how we run, we execute certain things against a container. It doesn't have to be PHP, of course. It could be MySQL. You could combine this with all sorts of different commands. So for example, a good one is MySQL dump. So you can do a quick MySQL dump of a MySQL database which is within a container. You can do that from the machine, no problem. I might demonstrate that in future tutorials, but that's basically a quick snapshot of how to use docker exec, docker execute. So if you've got any questions, then please let me know. Put them in the comment section below. If you found this useful, then do give it a like and subscribe to get the future videos. I've got a couple more Docker tutorials coming, as well as a couple of web development and programming rants and web chats that I occasionally have. Thanks again for watching, and I shall see you again soon. Oh, and before I leave, I'd like to just mention that I have a Docker machine set of tutorials that are pretty might be pretty useful to some, and would give probably a bit of background, a bit of insight as to other commands that I perhaps refer to when I do these tutorials. And also I have the 2 other tutorials. I put links in the descriptions and the links in the annotations and so forth for those. So do check those out, because things are going to get slightly more complicated now, and I don't particularly want to start explaining myself again and again and again. Lots of people are going to get bored if I did that, so do check those videos out. They might prove a bit useful. So again, do share this around, and like, subscribe, and all those things, and I shall see you again soon. Thanks. Goodbye. Hello, welcome to another How to Code Well YouTube tutorial. My name is Peter Fisher, and today's tutorial is the fourth in the Docker image and Docker container series. Today I'm going to demonstrate some more advanced Docker commands. I'm going to look at how to rename containers once we've created them. There's also a command that I'm going to add at the end that'll show you how to run a container pretty quickly compared to how we were spinning them up before. So like I said, this is the fourth one. Do check out the other three. It might be easier to watch those before this one, perhaps, because I'm going to skip over some commands that I've already explained. So, okay, the first thing I'm going to do is ensure that I'm in the right machine. So Docker machine active. So this will show the active machine. Should be how to code. Well, yeah, that's correct. And if I did Docker images and Docker ps-a, you can see that I've got a blank slate here. I don't have any images or containers. So let's just clear that down and do what we've done before, which is Docker pull, and we're going to just pull from ubuntu like so. So that's just going to grab the latest. This is what I've done in the previous videos. Nothing remarkable here. We just well, it is remarkable. We're pulling down an operating system, but you know, it's not something that I haven't done before. So let's just do Docker images just to get the image and the ID. And then if we did Docker run -it and then use the image ID, and we want to jump into bin bash. Okay, so we're now in the bash shell. I'm just going to drop out of that just so I've got the Docker container. So Docker ps-a, we can see that it's exited. Now notice that the name is pretty weird. So drunk wing. These names are automatically created by Docker if you don't specify a name to create. So for example, if I was to just do Docker run, there we go, Docker run, and exited out of view, clear the screen, and then did a ps-a, we can see that we've got another crazy name here as well. So there is a way of renaming these. If we did Docker rename, for example, we can we specify the name of the current container or the ID of the container, and then the name that we wish to rename it to, and that should now be set to test, and I'll do the same for the other one as well. There we go. So we can rename these containers. We can also change the name of the container as we run them. So what I'm going to do is just do a Docker no, I won't remove them. I'll do a Docker run. In fact, I've done that before, so I can go up here, Docker run. So we're going to do Docker run -it, so that's the interactive shell. But we're also going to do -- name, and we're going to give that test2, like so. So that should create a container with the name of test2 instead of one of these names that they automatically produce. So let's run that, then let's exit out of here. Let's clear the screen and then do Docker ps-a, and we can see that we've got test2 that's been added. So we can create containers with names, we can rename the containers, and so forth. Now notice throughout these tutorials I've been doing a Docker pull right at the beginning, and I've been pulling the image and then creating the container from that image. Well, we can actually do that in one go, which is something that I'm going to demonstrate right now. So let's just do a Docker rm, and I'm going to remove each one of these containers. But instead of doing it by the ID, I can actually now do it by the name. So test1 and test2. So there we go. Docker ps -a is empty, and Docker images, we have the Ubuntu. So let's do a Docker rmi, remember, we don't need a -f because we don't need to force it. We're going to remove that one here, and let's clear and do a Docker images. So we've started again from fresh. We don't have any images, and we certainly don't have any containers running. I can actually pull down an image and run it off the bat straight away without having to pull the image down. By default, when you do a Docker run and you try and run a container, or from an image that you don't have, it'll try and pull it down from whatever registry you're logged into. By default, you have access to the public registry. So I can do Docker run -it. I'm going to give it a name. So I'm going to call this, I don't know, foobar, right? And then I'm going to say Ubuntu, and because I'm doing it interactively, I want it to go into bin bash. Okay, so remember, I don't have any images and I don't have any containers at the moment. So what I'm doing here is I'm going to run Docker run interactively. When it runs, it's going to be I'm going to have a bin bash shell, so a bash shell. I'm going to give it the name of foobar, and I want the Ubuntu image. So I'm going to do that. So it's going to say unable to find Ubuntu latest locally, and when it means locally, it means that there isn't the Ubuntu image on this local machine. So then it's going to pull the image down. So it's going to do exactly what we were doing before, and then it's going to land me into the container with the bash shell like so. So it's a very easy way of creating containers and creating images just in a single command like that. So let's just exit out of here. So let's do an exit Docker ps -a, and we can see that we have the name of foobar. Notice also the image is Ubuntu. It doesn't have the actual ID of the image, and that's because the image name has also been changed to Ubuntu. So if I went to Docker images, we can see, yes, it is Ubuntu, and so forth. So that was a very quick tutorial on how we can manipulate the container names and also run the containers pretty quickly from images that we don't actually have on the system. We can pull them down pretty rapidly in one command. I hope you found this useful. If you have, please give it a thumbs up. Please like it and share it along. If you've got any questions or comments, then do leave them in the comment section below. I'll try and get to them as soon as I can. I try and publish a tutorial, or at least a web chat once a week, so do subscribe to pick them up. I've done some Docker tutorials before. This, like I said, this is the fourth one, so do check out the previous 3, as well as the Docker machine series of tutorials. As always, thanks very much for watching, and I shall see you again soon. Bye. Hello, welcome to another How to Code Well YouTube tutorial. My name is Peter Fisher, and this is the fifth tutorial in the Docker image and container series. I've also done a Docker machine series as well, so do check that out. I do recommend having a look at those previous videos because it might give you some background as to the things that I'm talking about and perhaps skipping over at the moment. So this tutorial, we are going to look at how we can search for images via the command line, because in the very first tutorial I did with the Docker images and containers, I showed you how we can access the Docker Hub, the Docker registry, which is the website of the Docker Hub, and how we can find and search images on that. But you can actually do that from the command line. So this is what I'm going to show now. So in order to search the Docker registry, it simply is Docker search and then a bunch of options, and then the term. So if I was to press enter, we get the usage here. So it requires at least one argument. So let's say I wanted to search for MySQL, and I did docker search MySQL. So that's going to now return a table of images here, and their descriptions, their stars, whether or not it's official, and a check for whether it's being if it's automated. So usually what happens is the official image gets the biggest amount of stars, and some of these can be quite long, quite a lot of contents and results that are returned. So there is a way that we can filter this list, and we would do this by the stars. So let's just clear the screen down. Now I can only return the perhaps I only want to return the images that have, say, 5 or more stars. So I would do that by docker search and then -s for stars, and then 5, and then MySQL. So that's going to return all the MySQL images that have 5 or more stars. So let's press enter, and here we can see a shorter list has been returned. So the one with the fewest amount of stars is 7. Okay, so that's this one here. And I can just do a docker run on this thing and pull it down. I'll demonstrate that now. So docker run. In fact, I will do, instead of a docker run, I'll do a docker pull and just pull that one down. So there we go. We're pulling that now. I don't know how big this will end up to be, so it might take a bit of time to pull it down. It's extracting it, so it's gone. These are all the layers, and it's extracted them. If I was to clear this, and I'll do docker images, we can see that we have that, and yes, it's 340 megabytes. That's fine. I'm going to remove this image. Docker rm-i. Oops, done it in the wrong order. rm-i, and it's. I'm just going to do it by the ID like that. There we go. So going back to the search thing. Let's just clear that down. If I was to do docker search -s, sorry, 5, and this time I'm going to do Redis. So this is looking for the Redis images. Now notice here that we've got the description here. It's being truncated. We can actually change that, so we can actually return the full description, and we would do that by doing -s5, because I only want 5 back. No trunc, trunc, like so, and we can see that we now have this extended description, and in some places it's wrapped around, which is can be quite messy on the screen. But if you wanted to read the whole thing, then we can do so. Also, what you can do is search for a specific image. So let's say this one, for example, we wanted to return. So what we would do is, let's clear the screen, do docker search, and we're just going to search for that. And there we go. So if I wanted to see just that, the description of this image, I would do trunc with a C, and there we go. So we can see that we have the whole description here. So if there was only one image that we wanted to find out and read the description, that's what we could do. Okay, so that's a quick demonstration of how we can search through the Docker registry. If you were connected to your registry, you can also search your own registry like that as well. If it was a private one, for example. I mentioned private registries briefly in the first tutorial. But I'm going to leave it there. If you've got any questions, then please let me know. Put them in the comment section below. If you've liked this video, if it's helped you at all, then please show your appreciation, give it a thumbs up, share it around if you think someone else could help by watching it. But as always, I appreciate your feedback, and I will see you again soon. Thanks very much. Bye. Hello, welcome to another How to Code Well YouTube tutorial. My name is Peter Fisher, and this is the 6th tutorial for the Docker Images and Docker Containers playlist. In this tutorial, we're going to focus on how to create a new user within a Docker container and how to connect to that Docker container with that user that we've just created. Because you may have noticed that in the previous tutorials, the user that we're connecting to these containers with is root, and in some cases that's not a good thing, especially for security reasons. Some applications, for example Jenkins, requires you to have certain users, i.e. a Jenkins user. So in this tutorial we're going to do that. We're going to create a container, we're going to create a user, we're going to log out of that container, and then we're going to connect to that container with that user. So as always, I'm going to double check that the machine that we're running is the How to Code Well machine. So I'm going to do Docker machine active, which is correct. That's fine. And as always, if I do a Docker images and a Docker PS, we can see we have no images and we have no containers set up thus far. So let's go and get some. So we're going to clear the screen and run Docker run Docker run -IT, because we want to do it interactively, and we're going to give it a name as well. So name is equal to, we're just going to call it test for now, and we want to get the Ubuntu image as always, Ubuntu, and we're going to run it against bin bash. So we're going to run this, download the Ubuntu image, create a container called test, and then we're going to run the bin bash shell. So this isn't an error, it's just saying it can't find it locally as always. So then it's going to download it from the Docker registry. That's perfectly fine, completely natural. This is what's happened in the last couple of videos, but as you can see here, we're in as the root user. So what I'm going to do is just clear this down so we can get to the top, and we need to create a new user in this container. So to do that, you would just use the standard Linux or the standard Debian commands for creating a user. So we would do add user, and we would give the user name that we want to create. So in this case, we're just going to create a user called Pete, and we're going to press enter. And this is just the standard stuff. So we've created a new group and created a new user called Pete. We've even created a new directory in home Pete. It's asking for the Unix password, so this is just normal stuff. And I'm not going to bother too much about all of this stuff, so I'm just going to press enter on all of these things, and I'm going to confirm that that is correct. So I'm going to press in Y. Now notice we're still as the root here, that's fine. But if we did cd /home and then did an ls, we can see that we have the Pete directory here. And if I did an ls -al against the Pete directory, we can see that the Pete directory is owned by the user and the group of Pete, and we have the bash bits and pieces all set up for us. So this is just the standard way of creating a user. So let's clear that down, and because I'm root, I can do su and Pete, so I'm going to change the user to the Pete user, and that's perfectly fine. So let's exit out of that, go back into root, and then let's exit back into the host machine. Now because I exited from an interactive shell, the Docker container has actually stopped. So if I was to do docker ps -a, we are going to need to start the container, because you can see it's exited. So docker start, and the reason why I called it test was it's easy to just use rather than the container ID. So docker start test, and then docker ps -a, we can see that we've started that. Okay, how do we execute a bin bash command against this container, the test container, using the Pete user? How do we do that? Well, normally, let's just clear that down. Normally, if I did docker exec -it, and we want to do it against test, and we want to run bin bash, normally we just dive into the root user by default. So in order to execute a command as a different user, we need to pass in a different argument. So to do that, we would do docker exec -it, but we'd also give it a -u, and the argument that we need to give is the user that we want to connect with. So everything there is the same as the top command, apart from this -u bit here, -u Pete. So if I was to press enter, we can see that now we are connected to this Docker container using the Pete user. So I'm now in as Pete. But please note, we are still in the root of the file system. So if I was to do ls, we can see that we have bin, boot, home, etc, all of that kind of stuff. So we're not actually in the, if I did print working directory, we can see that we are in the root of the file system. We are not, for example, in the home directory of the Pete user. So if I did pwd, we can see that that is the current working directory. So that's important to note. So when you connect to a Docker container, unless you've specified, you will go into the root of the file system. Okay, so that's a quick tutorial on how we can change and create users in containers and then connect to those containers from the host machine using those particular users that we've created. If you found this video helpful, then please do give a like, so I know that you found it useful. If you think that others can benefit from this video, then please do share this along. Subscribe to get the next future tutorials. I try and get a tutorial or a web chat out published every week, so do subscribe to get that. Thanks again for watching. If you've got any comments, then please leave them in the comment section below. As always, thanks for watching, and I shall see you again next time. Thank you. Bye. Hello, welcome to another How to Code Well YouTube tutorial. My name's Peter Fisher. This is the 7th tutorial in the Docker image and Docker container playlist. Do check out the previous 6 because they would give you some background information in how to use Docker, create images, create containers, and so forth. In this tutorial, however, I'm going to focus on how we can copy and paste files from the host machine to the container and vice versa, from the container back to the host. So as always, I'm going to ensure that we're running against the correct Docker machine active. This should return the How to Code Well machine, which is correct. And as always, if I did Docker images and Docker PS, we can see that we have no images and we have no containers thus far. Let's clear this down and then get some images. So Docker run, we're going to do -it because we want to do it interactively, and we're going to do we're going to give it a name. Going to give the container a name of just test 1 for now, and then we're going to grab the Ubuntu image and we want to run it as bin bash. So that's the command that we wish to run. Okay, so this isn't a warning, this isn't an error, sorry, this is just saying that we can't find the Ubuntu image locally, so that's going to go and grab it from the Docker public registry. That's perfectly fine. If you want some more information about all of this and what's going on, then do check out the videos, the previous videos that I've done. If I now do ls, we can see that we're in the root directory. I'm now going to do a touch to create a file. So this is just test.txt. And we can see that we have this test.txt file here. So we're going to exit this container. And if I was to do an ls, so we're back on the host. If we do an ls, we can see that we have no files in this directory. So in order to get that file that we've just put on the container, in order to get that and put that into this host machine, we would need to run a docker cp command. So that's copy and paste. And like the normal copy and paste command in Linux, the first argument is the source and the second argument is destination. So the source here would be the image name. So we've called this image, what do we call it? Test1. So test1 and then colon the path to the file. So in this case, it's just the root, and we've called it test.txt. and the destination is just period because we just want it in this folder. So if we press enter now and then do an ls, we can see that we have the test file has been added. Let's just move that now. Let's just rename that to be test1.txt and do an ls. We can see that we've just renamed that to test1. Let's put that into the container. Let's just clear the screen to give us some more room and do an ls so we can see it again. So as before, we do docker cp, but in this case the source is this file. So I'm just going to do period slash, because this is the current directory, and then test1, and the destination is the test1 container, and we're going to do colon, and we just want to push it into the root directory. So let's do docker ps-a, and that's fine, and let's do docker start to start this container, and then do docker exe minus it, because we want to run it interactively, and we are running against the test1 container, and we want to do bin bash, bash, like so. So let's just do an ls, and we can now see that we have the two files. This first, the second one, the test1 file, is the one that we copied from the host machine to this container. So I hope that's helped. I hope you found that useful. If you have, then please like the video. Do share it along if you think that someone else could find this useful. Subscribe to get the next series of videos. I've got a couple of web chats and more Docker tutorials coming. I try and release at least one a week. Also, do check out the previous Docker machine tutorials as well. I'll leave a link in the description and in the annotations at the end of the video. Again, if you've got any questions, put them in the comments below, and thanks again for watching. I shall speak to you all again soon. Bye. Hello, welcome to another How to Code Well YouTube tutorial. My name's Peter Fisher. This is the 8th tutorial in the Docker container series. Do check out the other tutorials on Docker containers, as well as the Docker machine tutorials, because they'll give you some background as to what I'm talking about in this one. In this tutorial though, we're going to focus on Docker ports and how we can expose ports from the Docker machine to the Docker container. In fact, in this tutorial we're going to create a web server, and this web server we're going to just run Apache 2, and in doing so we're going to expose port 80 on the web server, which is the container, against port 80 on the Docker machine. Okay, so let's get into it. So we're going to do Docker machine active. This is going to list the active machine, which should be the How to Code Well. Now I'm doing this just to double check what the machine is, but also I'm going to need to know what the machine is later on to get the IP address. So now we're going to do a Docker PS. We have no containers, and a Docker images, and we have no images. So let's go and grab one. Let's clear this down, and what I'm going to do is I'm going to do a Docker run, but I'm going to use some arguments that we haven't used before in the previous tutorials. I'm going to use some different arguments to expose the ports and so forth. So I'm just going to do --help, just to bring up the help documentation so I can talk about which ones we're going to use. And as before, we were using -i and -t. That would give us an interactive shell. In fact, in this case, we're not going to bother with -i, which is the interactive one here. We're actually going to use -d, which is up here, and -d here. So -d will detach the container. Basically, it allows the container to continue running. So if you have a service on that container or an application on that container, it will just run in the background. So that basically creates a background process, or background, it puts the container in the background, and then it prints the container ID, which is what I want to do because I want to show you what the ports look like when we use them. I'm also going to use -p, lowercase p here. So we're going to publish a container's port to the host. And so this is going to publish port 80 on the container to port 80 on the Docker machine. So let's do that now. I'm going to clear the screen just to give us some more room, and then do Docker run and then it was -t minus d, but we can also buddy those up like that, -td, and then I'm going to do minus name, and I'm going to give this a name, so web server. I'm also going to do -p, and I'm going to expose port 80 colon port 80. So that's mapping the port 80 on the container against port 80 on the Docker machine. And then I'm going to put in what the images that we're going to use. So I'm just going to use ubuntu like so. Okay, so docker run -td minus name web server -p 80 colon 80, and then the name of the image. Okay, let's run that. So it's going to say it's unable to find the image locally, which is fine because we don't have any images yet. So it's going to download it, and then it'll extract it. Then after it's done that, it will just print out the container ID, which it has done, but the Docker container itself is running because we've got the -d flag. So if I was to do, let's just clear that down. If I was to do docker ps, we can see that we have the Ubuntu image. We've pulled down the Ubuntu image. We've created the container. That's the container ID. The name here, it's wrapped around. I do apologize, but that's just because I've got a small terminal here. The name is web server. That's the name flag that we gave. We've also, this bit here, which is the ports, we've mapped port 80 and port 80. So that's the container, and that's the machine. We can also do docker ports, and then we give the name of the container or the ID of the container. So in this case, web server. That's going to list the ports that are mapped, because you can map obviously a lot of ports, different ports, port 22 for example, port 443, or whatever you want to the container and the machine. Also, you can map different IP addresses, so it doesn't actually need to be the machine, it could be something else, but in this example it is. So let's just press enter here, and oops, beg your pardon, it's docker, whoops, let's go back up, docker port rather than docker ports. There we go. So we can see that we've mapped port 80 from the container to the Docker machine. Okay, so this actually, I mean, thus far we've got a container, but we don't actually have Apache. We haven't installed Apache on it because it's just coming from the latest Ubuntu image, and of course Ubuntu by default doesn't have Apache installed. So what we need to do is just clear that down. We need to do a docker exec because we're going to execute -it because we want to do it interactively against the web server container, and we're going to execute the bash shell, so bin bash. This will just bring us into the container. Let's try that again. Sorry, sometimes it does that. Yep. So here we go. We're into the container now, and if I was to do apt get update, so we're going to update the sources like so. So this is just updating the sources lists and so forth. We need to do, I'm going to clear that down. We're going to do apt get install. We're going to install Apache 2. We're also going to install Vim because by default we don't have Vim, nor do we have Nano or any other sort of ability to edit files unless we use things like sed and so forth. But we're just going to use Vim because it's nice and easy. So let's just run that. So here we go. We're downloading, if I scroll up here, we're downloading the packages, so Apache 2 and all the dependencies, as well as Vim, and it's 151 megabytes of additional space. That's perfectly fine. Let's accept that and let it run. So here it's downloading all the bits and pieces, unpacking and installing, and it should be done soon. Yeah, excellent. So if I was to clear this screen to give us some more room, we should have cd, we should have etc Apache in here. Yeah, we do, if I was to list that out. And then we should have ls, or actually I'll do a cat of sites enabled, and then yep, that's the default virtual host. So I'm just going to display that. So I'm looking for, so this is the virtual host of the default Apache web server page. Document root is what I was looking for, so var www.html. So in this folder here we'll have in this directory structure here, we'll have an index file. So let's go and check that out. Let's clear that down and go into cd var www, and then it was HTML. I'm just going to list that, and yes, we've got the index page. Now, by default, this file here, if I was just to cat that out, just to show you, isn't going to be displayed if we went to the IP address, and that's because we need to enable this website. And sort of an easy way to do that is just to do an Apache restart. We've only got the one site on here, so that's perfectly fine, and just for this example. So let's just clear the screen down, and it is service Apache 2 space and then restart, Apache 2 restart. So that's now restarting. Don't worry too much about this this warning that's just come up. It's just saying that we can't find the server name, the fully qualified name. Don't worry about that. Not for this example. That's fine. Let's just exit out of this container. So we're back on the host machine here. Let's clear the screen down and then do a docker ps. So it's still running, so it's still up. That's perfectly fine. That's exactly what we need to do. What I can do now is do a docker machine IP. Now this is going to bring the IP address, how to code well. This is going to display the IP address of the machine that we're on. So let's press enter, and that's the IP. Okay, so the first test I'm going to do is just a simple curl. So I'm going to curl to that address. Okay, excellent. So that's displayed exactly the same file as what I was just displaying earlier when I was actually inside the container. This is a curl request. This is what's returned from the curl request, which means that if I was in, say, this browser, and I pasted in that IP address and pressed enter, we will see the default Ubuntu page, the default Apache page for default. Sorry, the default Apache page for Ubuntu, for the Ubuntu container. Okay, just to, another way to prove that we're actually in there is if we were to do a docker exe again. So we're going to jump into the bash shell here of the container. If we were to do cd var www and then HTML, we list that out. If we were to remove the index page, for example, so we don't actually have anything in here, we should now, when we go to the browser, we should just have the basic a basic index of page. So let's refresh the page, and we can see that we have this default, this basic index of, and then slash. So let's create some files. So let's just do a vim or a vi of let's say just test.html, and let's let's add some bits and pieces. So I'm just going to do h1. This is just very basic. I mean, hello world. Whoops, if I can spell it right. Hello world, like so, and then break that off. And then I'm going to right and quit the file, and then ls, so we can see the test is in there. And let's refresh this so we can now see that we have the test.html, and if I was to click on that, we can see the hello world. Likewise, if I was to exit the container here and do a clear and then do a docker, what am I doing? Docker ps. If I was to do a docker stop of the web server and then press enter, we can see, if I was to refresh that, that we can't connect anymore to that IP address because we've stopped the container and we've stopped any requests going to this because the container is down. One thing to note, however, if I was to do, let's just clear that down, if I was to do a docker start of the web server and then just ensure that that's up, ps, so it's now up. If I was to refresh the page like so, please note that it's still down. I'm refreshing the page here. It's still down even though the Docker container is up. Now the reason why this is happening is because the Apache service needs to be reloaded or restarted when the container boots. So when you're creating an Apache or even an Nginx for that matter web server, you need to create some scripts that manipulate the perhaps the process file, the PID file, or just every time the container starts up, you've got a hook script that makes the Apache service run. So in order to get this to run again, let's do docker. Let's jump on to here, go into the bin bash command, and then do a go up a few times. Let's just do an Apache restart like so. Again, don't worry about this message, and then come back here and then hit refresh, and we can see we're back in the hello world. Okay, so that's a quick tutorial on how we can expose ports in a container, expose the ports from the container to the host machine. In this case, it was the hello world, the how to code well Docker machine, and how we can actually create a very quick Apache 2 web server instance. I hope you found this video helpful. If you have, please give it a thumbs up. Do subscribe to get the other Docker tutorials that I'm doing, as well as my web chats that I've been publishing on the Fridays. If you've got any comments or questions, then please leave them in the comment section below. Do share this around if you think others might find this helpful. Once again, my name's Peter Fisher. Thanks ever so much for watching, and I shall see you again soon. Bye. Hello, welcome to another How to Code Well YouTube tutorial. My name's Peter Fisher. This is the 9th tutorial now in the Docker container series, and today I'm going to show you how you can easily identify the container that you're currently working on. If you have a lot of containers, for example, a lot of containers running, or just containers to deal with, it can be a little bit tricky to work out which container you're actually inside. So there are various ways to get around that, but I'll just do an example just to show you. If I was to do a docker run -it, we're going to use the Ubuntu image, and I'm just going to go into the bash shell. Now I've already got Ubuntu the image here, so that will just quickly create one. So here we can see that we're into this container. This is the container ID, and let's do an exit. And let's run another one, and exit, and let's run another one, and exit. Now notice that each one has obviously a different container ID, and this container ID is automatically created for us. We don't actually have much control over this. But if you've got, say, 3 or 4 or 5 or even more containers that you're working on all the time, it can be a little bit tricky to remember which container is which when you're just diving in and out. Obviously, we can do a docker ps -a, and we can list all the containers here with the container IDs and so forth. That's all well and good, and we can also give the names, change the name of these containers, which I've showed you before. That's fine. That's all well and good when you're outside of the containers, but when you're actually inside the containers and you can't remember if that one is that one or that one is this one, then it can be a little bit tricky to remember that. So a solution is to change the host name of the container, and so you can quickly identify where it is you are. So what I can do, well, let's just remove these for now, just to give us some room. So docker rm, let's remove them by the container IDs. So that one and this one, like so. Let's just do a docker ps, make sure they have all gone. Docker ps, like so. Good. Clear that down and do a docker run. I'm going to do a --- help because we're going to use another argument which I want to explain. So the argument that we're going to give is -h or -- host name. So this gives the container its own host name. So let's clear this down and do a docker run -it again to get it into interactively, and then a -h or a minus hostname, and we give the hostname here. I'm going to do test.local, and then the Ubuntu image, and we're just going to go into the bash shell. So let's just press enter, and we can see now that we have root at test. So test is the alias of test.local. Test.local was the host name. If I was to do cat, where is it? etc hosts, I think it is, with an S. Yeah. So we can see that we have this entry in this in the hosts file, test.local, and alias to test. Okay, so that's a very quick, easy way of creating containers which are slightly more identifiable. One thing I should note is if I was to exit this and do a docker ps again, we haven't actually, sorry, a docker ps -a, we haven't actually changed the ID or the name of the container. But if we were to do a docker, I'm going to have to start this, docker start, what is it called, this container, and then a docker exec -it of that container, and then we're just going to jump into bash like so. We can see that the host, the alias here is correct, and that's what it was set beforehand. So even though we've changed the container host, we haven't actually changed the container ID, nor have we changed the name as I've showed you in a previous tutorial. But I hope that that helps. If you've got a lot of containers, then this is a great way of easily identifying when you're within the container, which container you're actually in. So you could have, like, you know, at MySQL or at Apache or whatever. The next couple of tutorials down the line, they're going to look at Docker environments, as you know, environment variables, as well as Docker volumes and so forth. So do subscribe to pick those up. Leave a comment in the comment section below if you've got a question or just a general comment. I do appreciate those. I do pick those up and try and get back to you as soon as I can. Do subscribe, like I said, to pick up the next tutorials. Like this video if you found it useful, and share it around if you think someone else could benefit from it. Thanks again for watching. My name, as always, is Peter Fisher. You can catch me on Twitter at PFWD. Thanks again, and I will see you soon. Bye. Hello and welcome to another How to Code Well YouTube tutorial. My name's Peter Fisher, and in today's 10th Docker container tutorial, we're going to look at in Docker container environment variables and how we can set environment variables when we go to run the container, and how we can override those variables as well. So let's start it up. Let's do a Docker run, and I'm going to do --help to bring up the help file again. And we're going to use, in this tutorial, we'll use two new arguments. The first one is -e, if I can find it, -e, here we are, -e, set an environment variable, set environment variables. And then the next one is -env -file, and this reads a file of environment variables. Let's talk first about -e. So you can have as many of these environment variables as you wish with -e. So you can have as many -e flags as you wish, and that creates basically a key value pair, where the key is the environment variable and the value is the value that you want to set your environment variable to. Let's just do a demonstration. Let's clear this down and do a Docker run -it to get it interactively, -e. Now I need to do the key, which is for this example just mode. It can be whatever you want, and then an equals to a value, and that value I'm going to have as test. And then again it's going to be the Ubuntu image and then a bash shell that we're running interactively. So let's press enter here, and then do an echo of the variable mode, and we can see that we have test is the value, because test is what we specified here in the -e. And like I said, we can list lots of these things. So let's just do exit. Let's do a Docker run again, but instead of just having the single one, we can also do -e, and we can have, say, I don't know, doc root like that, and then equals to I don't know, /var ww perhaps. Run it again, and then do an echo. We still have the mode, and also this time we have the doc root as well, like that. So that's how we can inject environment variables into this Docker run command. Now, applications normally have lots and lots of these things that you can pass through, so it can become quite troublesome to keep listing them out like so. One thing you can use is the -env file. So that's a file that lists variables that you can inject into, which I'll demonstrate now. Let's exit out of here. I'm also going to do a docker ps, because we're starting to build up, sorry, docker ps -a, because they're inactive. We're starting to list a lot of build a lot of Docker containers, so I'm just going to remove these as I go. And that's the third one that I was playing with earlier before. Whoops. There we are. Docker ps to make sure they're gone. Cool. So what we can do is this docker docker run -env file. So first of all, we need to actually create this file, and if I did an ls here, we're in a blank directory. So let's go and create a file, vi, and then I'm going to do just env, and I'm going to call it env.list, because it's a list of stuff like so. And let's jump into it. So the first one I'm going to set is mode, and I'm going to set this as test. Second one is doc_root, and I'm going to set that as var ww, or yeah, var ww for now, whatever. And then let's come out of this. So let's write and quit, and ls, so you can see the file there. That's great. So I would do a docker run -it again, -env -file or -file, and then the path to this file. So it's just / and then the file name, and then again Ubuntu, because that's the image that we wish, and then bash like so. So here we are. And if I was to do an echo of what do we call it? Echo of mode, we can see we've got test. And likewise, if I did an echo of the doc root again, doc_root, we can see that is set there, because if I was to exit this and then do a cat of that list, these are the environment variables that we're injecting into this docker run command. Now, there is another thing that I would like to mention about the env file. You can use this file as like a template, as like the basis of the environments that you wish to inject, and then you can override those environments using the -e flag. I'll just explain that in more detail when I demonstrate. Let's clear this down. I'm going to do a docker ps again. I'm going to remove docker ps -a. I'm going to remove that container like so. Docker rm. Now notice that if I did a cat of that env, that the mode is set to test. Now perhaps we want to change this on the fly and change this to be dev, for instance. To do that, we would do a docker run -it again, -env -file, and then we would put the path of the file. We would also do a -e, and -e is just to inject an environment variable, and we're going to call this mode. Make sure it's the same variable as what we've got listed here, and we're going to just equal that to be dev, and then again Ubuntu as the image, and then bash as the command that we wish to run. That looks good to me, so let's press enter, And if I was to do this time echo mode, the mode has been changed to development, even though the mode here is test in the env list. Because we've injected it with the -e flag, we've set it to be development. We've overwritten the value there. Now it doesn't matter the order in which you put these in. You could have -e before the -env file, or after. I'll just explain. If I did an exit of this and did a docker run again, but this time I'm going to put this behind like so. So -e and then mode is equal to dev. Let's enter that, and then echo mode. It's still changed, it's still dev. We've still overwritten this mode. So it reads the environmental file first, the env file first, and then it then reads all the environment variables individually that you've injected in, which is great for, say, web development, where you've got sort of a list of all the basic, the fundamental foundation environment variables, and you wish to inject them or override them locally, which is great. Perhaps you want to change a port, perhaps you want to change a username or password to MySQL or whatever. So that's a great way of doing that. Okay, I hope this has helped you in any way. If it has, then like the video. Do leave a comment or a question if you have any in the comment section below. Subscribe to get the next few tutorials. I'll be focusing on Docker volumes and other bits and pieces later on. So do subscribe to pick those up, and also to listen to the web chats and web rants that I have every Friday. Again, my name is Peter Fisher. Follow me on Twitter, PFWD. Thanks again for watching, and I shall see you again soon. Thank you. Bye. Hello and welcome to another How to Code Well YouTube tutorial. My name is Peter Fisher. Today is the 10th video or 10th tutorial in the Docker Containers tutorial series. If you followed along, then please let me know. It'd be lovely to hear from you and find out what you think of the series so far. Today we're going to focus on volumes, Docker volumes, as well as how to create or bind mount host folders on your host machine to a Docker container. Now, this can trip a couple of people up. It certainly trips me up from time to time, and that's because if you do the configuration slightly differently, slightly wrong by perhaps mistake, then it can go off and do something slightly differently, something that you weren't quite expecting. So what I'm going to do is go quite slowly, and I'm going to discuss each point in a bit of detail. So do bear with me. Okay, as always, what we're going to do is a Docker machine active, just to list the active machine that we're running, and that's the How to Code Well. That's great. I'm also going to do a Docker images. This should bring up one image, the Ubuntu image. It's the latest one. I haven't done anything with it. And if I did a Docker ps -a, we can see that we have no containers here. That's fine. Let's clear that down. Now I'm going to talk about some arguments that I haven't talked about thus far. So we're going to do Docker run --help to list those out. So the arguments that we're going to use are the -v and also the --volumes from. So let's focus on this one first. So the -v or --volume, it's a bind mount of a volume. So you're bind mounting from your host machine to a container, and we can supply a lot of these, multiple amounts of these things, because you've got the comma there and so forth. So let's just clear this down and do that. Let's first of all, what we need to do is actually create a directory on this host machine for us to mount. So let's do an ls of the current directory, and as you can see, it's completely empty. So let's do a mkdir, and let's create a directory called data, cd into that data directory, and let's just touch a file. We're going to call this test1.txt. I'm just going to call it test, actually, like so. Let's do an ls. So we've created a file on this host machine. And if I was to ls again, we can see that that's the folder that we've just created. Fine. Okay, let's clear that down. I'm just going to bring that up for reference. Now what we need to do is a docker run -it, because we want to do it interactively, and we're going to give it a name of test1. So that's the name of the container. We're also going to do a -v flag, because that's the volume flag that I was just talking about. Now this flag comes with two aspects to it. The first, on the left hand side here, is the source. This is the source path. This is the path to the source that you want to mount in the container. And then on the right hand side of the colon is the destination. So this is the where you're mounting it to. So the path in the container that you want to mount to. Now I must stress that to do a bind mount, you need to use an absolute path. If you do a relative path, or if you just have a path that doesn't have any, if you don't actually specify the path and you just give it, say, a name, then it's going to do something totally different. I'll get onto that down the road in this tutorial. Let's just focus on this bind mount for now. So let's put in the source, and I'm going to do home directory, and it is the docker vid, like so, and it's the data directory that we've just created. And the destination of in the container, I want to do /data. So I'm going to put it in the root of the container in /data. As always, we're going to use the Ubuntu image, and I'm going to dive into the bash shell. So before I do this, I'll just explain. So docker run -it, we're going to run this container interactively. We're going to give the container a name of test1, and we're going to bind mount this host directory, which is my home directory, then docker vid, then the data directory, into a new directory called /data at /data. So in the root of the container, there's going to be a folder called data, and in that data folder, there will be that test file that I've just created. We're going to use the Ubuntu image like normal, and we're going to dive in using the bash shell. So let's just press enter and get in there. So let's do an ls. We're in the root of this container already, and we can see that we have this data directory created for us. If I was to do an ls of that, we can see that we have this test text file that we created on the host machine. Also, if I was to exit u, so I'm just going to come out of the container, and let's ls again. So we have this data directory. We're on the host machine. Let's do cd into data, and let's do a vim of test. And we're just going to put some bits and pieces in here. So let's just do test example, like so. We're going to exit u and right and quit that. So we've actually put some contents in this file. Now clear this. Now because I've exited the container, I'm going to have to start it again, and I think I called it, let's just do a docker ps -a, my memory, yes, it's test1. So docker start test1. So start that up, and we're going to just dive into here and see that the contents were changed. Let's do a docker exec -it to the test1 container, and let's jump into the bash shell. And if I was to do an ls, we can see that we have this data directory again, cd into that, and then ls, so we can see the file. And if I was to cat that file, so test.txt, we can see that we've actually got the contents. So the contents were changed on the host, and it's being reflected in this container. So we've bind mounted this directory, the data directory, into this container, and it means that we can manipulate the data or the files in this directory from the host, which is fantastic for things like web development, where you're creating you've got a container of a web server perhaps, or Apache or Nginx or whatever, and you're developing a website, but you're developing it on the host machine, and you're using an IDE like Sublime Text or NetBeans or whatever to create the website, create the files and so forth. But the actual development environment, the actual environment of where the website is in a series of containers that you've got on your development machine, and so any changes that you do to the files of the website get reflected in the container, which is really useful. I do that all the time. Let's just come out of here. Let's do an exit of that, and let's clear down the screen. One thing I would like to just show is how we can debug mount points and so forth. So I'm going to do a docker -- help. So what we're going to use is a command called what's it called? It is sorry, here we are, inspect. So we're going to do an inspect of a container. So let's do a clear this down and do a docker ps -a. Let's do a docker inspect of test1. Okay, so this returns the JSON, big JSON payload of information about the container, and the one I was looking for is this mounts bit here. So we can actually see that the destination here, and we've got RW, which is read and write, and the propagation and where it is on the file system. Okay, let's just clear that down. Let's do another example. Let's do a docker ps -a docker rm. We're going to remove this. We're going to remove the file. Sorry, we're going to remove the container. So test1. We're also going to remove what we've created on the host machine. So rm -rv data. So that's going to remove that folder and the file that we've created inside. Now, the next thing I'm going to demonstrate is creating Docker volumes. So these are slightly different from bind mounts, and the configuration is subtly different. So let's do that. Let's do docker ps just to make sure that nothing is there. That's great. Clear that down. So we're going to do a docker run again -it because we want to do it interactively. I'm going to give it a name of test2, and this time we're doing it -v, and we're going to create a volume, a Docker volume. So we're not doing a bind mount, we're doing a Docker volume. So we're going to call this data, and the destination is /data again. And we're going to do the ubuntu image, and we're going to dive in as the bash shell. So we're doing it, we're creating a container, we're calling it name2, we're doing it interactively, we're going to land in the bash shell off of the Ubuntu image. Please note though that I haven't actually given an absolute path to a folder to what I want to bind mount. So we're not actually doing a bind mount here, we're just creating a volume, a Docker volume called data. I'll explain what one of those are in a minute, and we're going to mount that into the data folder here. So let's do that. And again, if we were to do an ls, we can see that we have the data folder here. But if we did an ls of data, it's completely empty because there is nothing in it. So we've actually created a blank mount point, and we've given it a name of data in this container. So this is really useful for sharing or keeping data, persisting data when you have lots and lots of containers. And you can have lots of containers that share this data volume. And what it's done is, if I was to exit this, is if I was to do another command that I'll show is docker volume ls. So it's actually created a Docker volume called data. So this didn't actually happen beforehand because we were bind mounting. This is only happening because we didn't supply an absolute path to this source. We've created this, so we've created a Docker volume and we've called it data. Now there are other commands that we can do against the Docker volume, such as if I did Docker volume -- help, we can see that we can create a volume, we can inspect, we can list, and we can remove volumes. Now this is the reason why this is so good is because we're actually decoupling the container from the storage. So the container from the volume, we can share this volume amongst different containers as well, which I'll get onto later on in this tutorial. So we can actually create a container, attach this volume to this container, put some bits and pieces into it, delete the container. That's not actually going to delete the volume. Create a new container and attach this volume to the new one. So let's clear this down. Let's do a Docker PS because I can't remember whether it's it's exited. So let's do a Docker start of test2 like so, and also let's do a Docker exec -it test2, and we're going in as bash, and let's do a cd into the data directory. This is the volume, and also let's do a touch of test1.txt. So we're creating a file ls in here. Let's do an exit of that and a clear of the screen. Do a Docker ps -a. Let's do a Docker rm -f. We're going to remove this container like so, Docker ps -a, and we can see it's gone. However, the Docker volume is still intact. Docker volume ls, we can see that we still have this data directory here, and we can create a completely different container and we can attach it to this data volume and still use the files that we've created in here. I'll just do an example. If we did a clear and a Docker run, we're going to give this a name, -it, give this a name of test 3 now, I think it is, and then we're going to do a -v data, and it's going to be /data, and back into the Ubuntu image, and we're going to go in as a bash shell. So we're going to do, that doesn't look right. Let's -it because we want to do it interactively. Docker run -it interactive container. Give it a name of test3. The volume that we are using is the data volume. Now, because the data volume exists, we obviously don't recreate it. So we're just going to attach that existing volume. We're going to again use the destination of /data using the Ubuntu image and going in as the bash shell. Let's press enter here like so. Created a completely new container, and if I was to do an ls, we can see again we have the data directory, cd into data and ls, and we can see the file. So that's an example of creating containers that are pretty decoupled from the volumes, and we can remove the containers. It's not going to remove the data that we've attached, the volumes that we've attached, and we can spin up another container and attach that volume to the new container. Let's exit this. Let's do a clear and then a Docker ps -a, and then a Docker rm -f of test3. Test3, not test2. There we go. And Docker volume ls. Let's remove this volume, Docker volume rm of data. Now I'm going to show you another volume command. Now I'm going to do the Docker run --help. We're going to do this volumes from command. So this volumes from command will allow us to mount the volumes from a specified container to a new container. Okay, so this is really useful when you've got a container that has, say, a lot of log files, and you want to create a container that just handles those log files, perhaps parses those log files out in like a piece of software like Go Access, or has some sort of way of auditing and managing log files. Perhaps it's a firewall, and it's scanning those log files for intrusions and stuff like that. Let's just clear this down. I'll give you an example. Clear that. Docker ps -a, we have no containers here. Docker volumes, or volume -ls, or ls, we have no volumes. So let's do a docker run -it -name. In this instance, we're going to call it master, and we're going to do -v. We're going to create a volume called backup, and we're going to whoops, that's wrong. There we go. We're going to mount that to /backup. We're also going to create another volume. We're going to do -v again, and we're going to do logs, and we're going to mount that to the logs file folder like so. Again, use the Ubuntu image, and we're going to go in as bash like that. Okay, so Docker run, doing it interactively, giving it the name of master. We've got two volumes that we're mounting. The first one is the backup, second one is logs, going into /backup and /logs. These volumes, they don't have the absolute path, so these aren't bind mounts. These are going to be created as Docker volumes, and we're going to give this the name of master. Let's dive in, do an ls, and we can see that we have this backup directory here. We also have the logs directory. Again, these are totally empty, so ls backup and ls, what did I call it, logs. Let's do a touch. Let's just create a file in the backup directory, and we're just going to call this bkp1.tar, and a touch of temp1.log, in logs, temp1.log, like so. And let's do, just to show that they're actually in there, let's do an ls of logs and an ls of backup. There we go. So we've created a master container, and this master container has produced a log file and a backup file. Let's exit this container, and let's clear the screen, do a docker volume again, just to list these volumes. So we've created these volumes as we created the container, the master container. Let's use the volumes from command. Let's create a container and mount all of these volumes in one. So by doing so, we do a docker run -it to do it interactively, -name. We're going to call this slave1, and the command is --volumes -from. We're going to give the container name. This is the name of the container that we want to attach the volumes from. So this is master. And again, we go in as the Ubuntu image and bash shell. Okay, so Docker run, we're doing it interactively, giving it a name of slave1, so that's the name of the container. Volumes -from, we give the master container. This is the container name that we just created. We're going to mount all the volumes from this master container, going in again as the Ubuntu image and the bash shell because it's interactive. Let's do that. So we've created a completely new container here. We've called it slave1. And if I was to do an ls, we can see that we have the backup directory, and we also have the logs directory too. If I was to do an ls of backup, we can see that that is the backup file that we created from the master container, as well as ls of logs, and that is the temporary log file as well. So let's exit this, and let's do a docker ps -a. These are the two containers that we've created, the master and the slave. So you can imagine that like this slave container does things to the does things to the files and the folders that were mounted from the master. Perhaps it's on a cron or something, or perhaps it's doing something to the logging, and perhaps it's putting the backup somewhere, or whatever, doing some sort of rotation type thing, or anything really. Let's do a clear. Let's do a docker volume, because there is another command that I would just like to show you, and that is the inspect command of the volume. Let's do a docker volume ls and do a docker inspect. Sorry, no, it's docker volume inspect. Docker volume inspect, and we're just going to do the backup volume for now. Let's just press enter. So this is just going to return some low-level JSON information about the Docker volume, so we can see the driver and the mount point. Now the driver can be, you can assign different drivers to different volumes if you have different drivers that manage different volumes and so forth. So you can have different drivers that handle different ways of sharing between machines, perhaps. Local driver just means that it's local to this Docker machine. That's the mount point, and that's the name. And before I showed you the Docker inspect, which just gives a bigger list. I'll do that again actually. Let's do a clear of this and do a Docker inspect of master. So that's all the JSON information of the master container, and there is, here we are, 2 mount points here, logs and backup. They both have read and write access, so you can supply what level of access as well that you can do when you create the containers, the drivers and the destinations and so forth. Okay, I've rabbited on for quite a bit today in this tutorial, so I shall leave you there with this. This is an example of Docker volumes and mount points, or bind mounting the Docker files. Sorry, bind mounting local files from your local machine. It's very useful, and it's one of the top reasons why I like Docker so much, and because it's so versatile. So if you've got any comments or questions, then do leave them in the comments section below. If you've liked this video, then show your appreciation, give it a thumbs up, share it around to anyone who you might think might find this useful. As always, my name is Peter Fisher. Follow me on Twitter. My Twitter handle is PFWD. Thanks again, and I shall see you next time. Cheers. Bye.